Hey everybody, thanks for joining me. Today we're going to get into multiplying and dividing. We're going to try to bring up some of the issues that are going to cause the most trouble along the lines. Maybe things that you have forgotten or things that you haven't done in a few years and you may remember them, but you're a little bit rusty. So let's get right to it here. The first thing you need to know when you're setting up a problem like example number 1 is that a negative times a positive is going to be a negative. So your final answer is going to be negative something. Now, in this case, if you remember the old school way, if you have a different way of doing it, I'm not really sure what works best for you, but no matter how you slice it, you should get negative 68. All right, now, another thing to bring up here when you get to example number 2 is that multiplication is commutative. So if you want to treat it like negative 22 times 8 instead of 8 times negative 22, it's all good. There's nothing wrong with no matter how you slice it, you're going to end up getting the same answer. So in this case, you're going to end up getting 176, but remember it was a positive times a negative, so make sure your final answer is written with a negative, so that would get you negative 176. All right, example number 3, you've got a 2-digit number times another 2-digit number. Now, I have been told there are 100 different ways to do this now. As students coming up through grade school are learning different tricks, they might have a different way of doing it. I'm just flashing back to how it was done when I was growing up, and you had to put the 0 down as soon as you got to the as soon as you got to the second set of multiplication. That way you would start with the tens place and you'd end up getting 294. If that looks familiar to you, then go with it. That looks great. If you've learned a different way, that's good too. I've seen people do 2-digit multiplication with a box, all sorts of tricks. It's all good. I actually use the box when I do factoring later on. That's just how I operate, but whatever works for you is fine. All right, example number 4. You've got negative 3.1 squared, which means you've got a negative 3.1, and then you're going to multiply it by another negative 3.1. Now, there are two things I want you to take out of this. First of all, because you're dealing with a negative inside the parentheses, your final answer is actually going to be positive. So, when you do the process, and I'm not going to waste your time, it would be like example number 3, where you would put the 3.1, 3.1, you'd put them on top of each other, and you'd multiply that way. When you do the process, first thing to know is that your answer will be positive. Second thing to know is that if you did 31 times 31, you would get 961. Doesn't really surprise anybody. Now, the way to get your final answer, if you were having trouble figuring out where the decimals went, is since you have one number to the right of the decimal here and one number to the right of the decimal here, your final answer is going to have 2 numbers to the right of the decimal. So your decimal point is going to go between the 9 and the 6, and you will get 9.61. All right, let's get into division a little bit here. So you've got negative 190 divided by negative 5. And if you were doing this one written out the long way, you would end up getting 190, and you'd put a 5 over here. 5 goes in the 19 3 times and all that. I think you have seen that a bunch, so we'll do it this time, and then we won't bother again. No matter how you do it, you should get 38. And since it was a negative divided by a negative, your final answer should be a positive. All right, negative 25 divided by 50. 25 is just half of 50. And I think most of you probably knew that. So in the end, I'm not going to worry about doing much more than just calling this negative 1/2. Now, if you want to call this negative 0.5, I didn't really specify, so in this case, either one would be just fine. I've said this before, my general rule is if your initial problem was written as a fraction, your final answer should be written as a fraction as well. If your initial problem was a decimal, your final answer should be a decimal. And in a problem like this, I didn't really specify, so I really think either one would be just fine. And more often than not, if I get a situation like that, I'm going to accept either answer no matter what. All right, example number 7 here, you've got 42 divided by negative 168. That means your answer is going to be a negative. And if you started reducing this, and again, you could either treat it the long way like we did on example number 5 where you actually write things out, or you could just start reducing the fraction and just see what goes into what. Eventually, you would find out that the answer is negative 1/4. It turns out 42 is actually 1/4 of 168. Now, if you were a decimal person and you wanted to go with the 0.25, again, I didn't really specify, so there's not really anything wrong either way. All right, let's keep going here. Let's get to this next section. And again, I talked about this since my initial question was written with decimals. I think my final answer could be written with decimals as well, and I don't think anybody would complain. In this case, I'm going to set it up like this. And since my initial problem had 2 numbers to the right of the decimal, my final answer will be the same. So I'm going to put it between the 5 and the 6. And it turns out 0.78 times 20 is 15.6. Now that trick about bringing the 0 down, it's basically me saying, hey, I'm going to multiply by 10, which means I get to throw an extra 0 in there. All right, we've got more division here. We're sort of bouncing around trying it with multiplication and division mixed together here in this third section. And we've got a decimal in the denominator. Now, if you've ever seen somebody move the decimal over one spot here and then put a decimal here and move it one spot, the reason they're doing it is because you are technically allowed to multiply the numerator and the denominator by 10. That's what just happened, is I took the numerator, multiplied it by 10, the denominator multiplied it by 10. So that's a decimal trick that people use, and it works really well, so you can just go with it. And then it seems to make more sense because now you don't have to worry about decimals, you can just finish the problem. Let's try that with example number 10 so you can sort of see what I'm getting at here. This time around, though, I am going to move the decimal another spot here as well. Let's see, negative 9.25 divided by negative 2.5. Now, you've got so many different ways to approach this. If you move the decimals twice, you end up getting 925 over 250. I don't know if that really helped a lot. It seems to me like you might be better off writing it out the long way, or again, at some point you're probably just going to say forget it and you're going to use a calculator, but I'm just trying to demonstrate all the different ways these could be done. If you were to try and start reducing this, the first thing that I would notice out of the deal is that 25 goes into both of these. And if you were to put 25 into both of them, you would end up getting 37 over 10. Now, since the initial problem was written as a decimal, I'm going to take my final answer and write it as a decimal as well, and I'm just going to call it 3.7. All right, now, when you get a problem like 11 with negative 0.4 cubed, that means there's going to be 3 of them. It's going to be negative 0.4 times negative 0.4 times negative 0.4. And it would be really easy to get bogged down by the details here. So let's just cut to the chase. If you have 3 negatives, 2 of them are going to cancel out, 1 of them is going to stay there. So this negative times this negative is going to become a positive, but the third is still going to be there. Next, 4 times 4 times 4 is 64. Last but not least, in case you didn't notice, we have 1, 2, 3 total digits to the right of the decimal. That means when we do our final answer, we also need to have 3 total digits to the right of the decimal. So your final answer would actually be negative 0.064. Whew. All right, we made it through that section. Let's go through the fractions real quick. Multiplying with fractions, I think in most cases would be considered easier than adding or subtracting because all you have to do is go straight across. 1 times 3 is 3. 9 times 5 is 45. Reduce it when you're done. Now, if you have the tricks from the past for cross-canceling, that's all fine and good. I'm just going to go straight across and just try to get this thing done. So you can either cross-cancel in the beginning, you can reduce in the end. It's all pretty much the same to me. All right, whenever you divide, that means you're going to flip the second fraction. You're going to flip what you are dividing by and then multiply. So when you flip that second fraction around, you're going to have the 7 on top. And a negative times a negative is a positive, which means your final answer will be 35/8. All right, just a couple to go here. It looks to me like these two numbers seem to be inverses, as in when you multiply them, you should get 1. The 3's are going to cancel, the 8's are going to cancel, but it's not quite that easy because one of them is negative, the other one is not. So it turns out when you multiply this, let's just pretend you didn't notice that and you were just going straight across. 3 times 8 is 24, 8 times 3 is 24, and then a positive times a negative is a negative, and you would get -1. So these numbers are not actually inverses of each other because what you were left with was not 1, it was -1. Now example 15, on the other hand, these are inverses of each other, and the reason why is because you have a negative times a negative, which is going to become a positive, and 1/5 of 5 is 1. So this would be an example of the inverse property of multiplication, whereas example 14 would not be. All right, thanks for joining me. I appreciate your time. Good luck the rest of the way.